Hello everyone, let me introduce myself. My name is Uskar Sabila Mupinin and I'm from Department of Mathematics, Faculty Science and Mathematics, Diponegoro University. Now, I will present to you our research about a traveling salesman problem using fuzzy logic approach for tourist destination route in Semarang. This research was presented on International Conference on Mathematics and Mathematics Education, Patimura University 2020, Ambon. This is the abstract of this paper. The main features of the topic are fuzzy sets and traveling salesman problem. Fuzzy set theory was firstly introduced by Zadeh in 1965. Is a mathematical framework used to present uncertainty, ambiguity, inaccuracy, lack of information, and partial truth. This fuzzy set is based on value between 0 until 1. The traveling salesman problem. In a traveling salesman problem, a map of cities are given to the salesman and he has to visit all the cities only once and return to his starting point to complete the tour in such a way that the length of the tour is the shortest among all possible tours for this map. The data simulation of this paper, we use the data of road length data and average time travel data that are shown on table 1 and table 2 with the place name information as follows: 1 for Lawang Sewu, 2 for Pagoda Buddha Gayas, 3 for Sampokong, 4 for MAJD or Great Mosque, and 5 for Old City. The process of this making the optimal route. Step 1 is fuzzify the data simulation into a fuzzy set and define the membership value. Step 2, we define the fuzzy rule and also define alpha minus predicate. Step 3, calculate fuzzy output using weighted average. And step 4, determine optimal tourist destination route in Semarang using traveling salesman problem on dynamic programming. Let us start to step 1. Step 1 is fuzzify data into fuzzy sets and determine the membership value. On the screen we can see that is the fuzzified average time travel data into fuzzy sets, and that's membership value, and the figure 2 for the membership function. And then the step 2, define fuzzy rule and alpha minus predicate. In this case, we built 9 fuzzy rules that are R1, R2, R3 until R9. The step 3, calculate fuzzy output using weighted average method. We define alpha minus predicate for all fuzzy sets of road length data and time travel data. For example, we define alpha minus predicate of Lawang Sewu to Pagoda Buddha Gayas fuzzy sets. Its road length fuzzy set and average time travel fuzzy set shown on the screen. The criteria of each rule as Z1, ZY, ZI are shown as follows: near, medium, rather far, far, and very far. And then they calculate fuzzy output using weighted average method that are R1, R2 until R9. The next step is calculate fuzzy output using weighted average method because of only R6 which has alpha minus predicate value, so we define fuzzy output value of Lawang Sewu to Pagoda Buddha Gayas fuzzy set only using R6. It is represented by calculations as follows. So we can get Z star is equal to 1, so the output of fuzzy sets of Lawang Sewu to Pagoda Budaya is equal to 1. And then do the same calculation of all fuzzy sets until we get the following table. The table 5 is the final output fuzzy. Step 4. Calculate optimal route using traveling salesman problem. We determine optimal tourist destination route in Semarang using traveling salesman problem on dynamic programming approach. For these calculations, we use the help of Python 3 with the syntax input is shown as following figure. And then the result of these calculations is we get optimal route that is shown as following graphic, with the red line for using fuzzy output, green line for only using route length data, and blue line for only using average time travel data. The conclusion of this paper is this method can be used to plan the trips with uncertain conditions. However, we cannot only use one parameter in this case, because if we only use one parameter, for example, we only use route length data, we cannot predict that we will come to each destination on time more accurately. We will not know whether during the trip we will encounter some traffic jams or etc. So, by adding more parameters, it will help us to get optimum destination route more accurately. The final result of this paper is getting optimal route of 5 tourist destinations that are Lawang Sewu, to Old City, to Masjid Agung Jawa Tengah or Great Mezki, and then Pagoda Budaya, and the last one is Sampokong. I think that's all. Thank you for your attention. See you.